In this video, we're going to talk about the law of sines. We're going to talk about a brief explanation and then do some examples. So the first thing that we need to talk about is solving oblique triangles. Trigonometric functions can also be used to solve triangles that are not right triangles. These triangles are called oblique triangles because they contain oblique angles. Acute and obtuse angles are also known as oblique angles. Any triangle can be solved if at least one side and any other two measurements are known. So looking at the pictures I have on the left and the right side, on the left side we have the law of sines, and using the law of sines, if we know angle, side, angle, 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 side, or side, side, angle, we can use the law of sines to find the other sides and the other angles of our triangle. Using the law of cosines, we can solve a side, 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 or a side, angle, side triangle. Note that we cannot solve a triangle if only all three angles are known, since the angles only tell us the shape of the triangle and not the size of the triangle. So the first thing that we're going to do is we're going to derive the formula for law of sines. Starting with an oblique triangle, which is my picture I have on the screen, we're going to cut the triangle into two right triangles by dropping a perpendicular line from one angle. Here I chose angle C. And when we drop that perpendicular line, we're going to label that the height h. So using the definition of sine, we have sine equals opposite over hypotenuse. Looking at angle A first, we're going to get that the sine of A equals the side opposite, which is h, over the hypotenuse, which is B. Then we're going to find the sine of angle B. And again, side opposite is h over my hypotenuse A. Solving both of these for h, I'm going to get h equals b times sine A. And solving for h over here, I get a times the sine of b. Since both of these now equal h, I can set them equal to each other and get b sine A equals a sine of b. And rearranging that, I can get the sine of A divided by little a equals the sine of angle B divided by little b. So now we have this relationship between the sine of our angles and the lengths of those corresponding sides. Note that drawing altitudes from angles A and B would give ratios involving the side length C and our angle C. So if we look at the formula for law of sines, for any triangle ABC, we have the following relationship. The sine of angle A divided by the length of A equals the sine of angle B divided by the length of B equals the sine of angle C divided by the length of C. Therefore, in any triangle, the sides are proportional to the sines of the opposite angles. So as I said on the first slide, the law of sines can only be used to solve triangles of the form angle, angle, side, angle, side, angle, and side, side, angle. And we're going to look at some examples of solving those types of triangles. So here's an example of angle, angle, side. And I want to note here, if you have an example of angle, angle, side, or angle, side, angle, you're going to solve these basically the same way because you know two angles out of the three angles. And when we know two angles, it is very easy to find the third angle because all of the angles in my triangle must sum to equal 180 degrees. So that's really the first step that we want to take here. I know that all of my angles must add together to equal 180 degrees. So I can very easily solve for A, and A is going to be 180 minus 38 minus 21, and so that gives me 121 degrees. So now that we know all of our angles, we can use the law of sines. Sine A over A equals sine B over B equals sine C over C. We can use the law of sines to now find the length of side A and side C. So I have the sine of B, which is 38 degrees, over side B, which is 24, equals the sine of angle A, which we just found to be 121, over the side of A. So that's going to give me A equals the sine of 121 divided by the sine of 38 divided by 24. Putting that all into my calculator, sine of 121 divided by the sine of 36 divided by 24. That gets me A is approximately 33.4. Okay, and finally we need to solve for the side length C. So again, the sine of 38 over 24, the side of C, which is 21, over my side C. And that's going to get me C is approximately the sine of 21 divided by the sine of 38 divided by 24. That gets me 13.97. So C is approximately 13.97. And again, if we have angle side angle, we would solve this triangle in a very similar way. So I'm not going to do an example of that. I'm going to go straight into this side angle because these are a little bit more complicated. If the given angle is acute, then there may be no solution, one solution, or two solutions. And we can see why this happens if we look at some pictures. So in this case, we're looking at when B is an acute angle. So if we look at this first picture here, if B is less than our side C, then it's too short to reach all the way down here, and in which case we would have no solutions. If B just reaches the base and it's perpendicular to it, then we're only going to have one solution. If an arc of radius B meets the base at 2 points, then we can have two solutions, as you can see in this third picture right here. If we look at case 4 down here, we can also again only have one solution. If an arc of radius B meets the base at just 1 point other than that angle B. And case 5, again only one solution if the arc of a radius B meets the base at just 1 point. So as you can see, our side angle, when we only know one angle, can become very, very complicated. Because now if we look at the case where we're given an obtuse angle, there can also be no solution or just one solution. So again, looking at some pictures, here we have B is an obtuse angle. Again, if that side length of B is too short where it's not going to reach that base, then we have no solution, which can be seen in case 6 and case 7. And then in case 8, where we finally get one solution, an arc of radius B meets the base at just 1 point. So now we're going to look at an example of side angle. We have solved the triangle, if at all possible, because we could have no solutions, where our angle B is 115 degrees, the side length B is 23.8 yards, and the side length C is 45.6 yards. So here, using the law of sines, we get the sine of angle B over the length of side B equals the sine of angle C over the length of little c. So plugging in what they've given us, I get sine of 115 degrees over 23.8 equals the sine of C over 45.6 yards. So solving for my angle C, I get sine of C equals 45.6 times the sine of 115 divided by 23.8. And then again, to solve for my angle C, I need to take the sine inverse of both sides. So I get the sine inverse of 45.6 times the sine of 115 over 23.8. So putting all of that into my calculator, I get the sine inverse of 45.6 times the sine of 115 divided by 23.8. And as you can see, I get an error. So the minute that you get an error in your calculator tells you that you have no solution. So here, my final answer is no solution. So now we're going to look at, again, another example of a side-side angle. We have the side length B equals 8.6 centimeters. The length of side C equals 6.2 centimeters. And our angle C equals 35 degrees. So as you can see, I've drawn my picture here. And I left this part open because I don't know if that's going to reach based on the arc that that side length C is going to make. I could have no solutions, one solution, or two solutions. So that's kind of why my picture looks a little funny, but I wanted to emphasize the fact that we don't know really what that picture looks like. So the first thing that I'm going to do is I'm going to use the law of sines in order to try and figure out what the angle B is. So I have the sine of angle C, which is 35 degrees, over the length of C, which is 6.2, equals the sine of B over the length of B, which is 8.6. Again, I need to solve for that angle B. So I get the sine of B equals 8.6 times the sine of 35 over 6.2. And again, taking the sine inverse of both sides, I get B equals the sine inverse of 8.6 times the sine of 35 degrees over 6.2. All right, putting that into my calculator, I get sine inverse of 8.6 times the sine of 35 degrees divided by 6.2. And that gets me B is approximately 52.712. 52.712. Okay, now in order to find the second solution, we need to find the supplement of this angle. So recall that in order to find the supplement of an angle, I need my two angles. So x is what I'm trying to find. This is what I just found. And I need them both to add together to equal 180 degrees. So solving for x, I get x equals 127.288 degrees. So this is actually going to be my second solution for B. So B can also be 127.288 degrees. So now that I have two different values of what my angle B could be, I now need to solve for the rest of the triangle. So on this page, I'm just going to go ahead and write everything that I have for my first solution. So they already gave me C equals 35 degrees. The length of side C equals 6.2 centimeters. And the length of side B equals 8.6 centimeters. On the previous screen, we just found that my first solution For my angle, B equals 52.712 degrees. So I still have left to find angle A and the length of side A. So in order to find A, I can simply say 180 degrees has to equal all of my angles. So 35 plus 52.712 plus my angle A. Solving for angle A, I get A is approximately 92.288 degrees. Now I'm going to use the law of sines to find my side A. So I have the sine of A over A equals the sine of C over C. So the sine of A, which we just found to be 92.288 over the length of side A equals the sine of 35 degrees over 6.2. And solving for the length of side A, I get approximately 10.8 centimeters. And then again, I have my second solution. Rewriting everything that they gave us, 35 degrees for angle C. Side C is 6.2 centimeters. Side B equals 8.6 centimeters. And on that first screen, we just found that B equals 127.288 degrees. So again, we still have to find angle A and the length of side A. So to find my last angle again, 180 has to equal 35 degrees plus 127.288 degrees plus angle A. Solving for angle A, I get angle A is approximately 17.712 degrees. Using the law of sines, I get the sine of angle A, 17.712 over the length of side A has to equal the sine of 35 over 6.2. And solving for the length of side A, I get 3.29 centimeters. So here is all of our second solution. Again, here's our first solution. And that all goes back to solving just for this one triangle for a side-side angle. So please make sure that on side-side angle, you are considering that for an acute triangle, which in this case we had 35 degrees, we could have possibly had no solution, one solution, or two solutions. For an obtuse triangle, it's a little easier because our only possibilities are no solution or one solution. So that's really all you need to know about the law of sines. Keep in mind our equation right here where all of the sides are proportional to the sines of the opposite angle.